Today's lesson is going to cover parent function checklist. We're just going to go over some of the parent functions that we'll be studying over the course of the semester, actually the school year. And I want you guys to notice, please don't be intimidated. This is a pre-calculus handout. However, pre-cal is just like Algebra 2, okay? It's like Algebra 2 or 2x or something like that, okay? So I do like to include pre-cal problems or handouts from pre-cal, so don't be intimidated by that. So let's move on. The first function that we have here, it is f of x is equal to x. You can see the graph here, and here what I would like for you to do is please include some arrows, because that is one of the errors with technology. They don't give us the correct picture sometimes. All right, so the arrows, that means that the graph is extending indefinitely, and that becomes very important when we talk about domain and range. Now, I know that you guys have seen this function since probably middle school, right? Does anyone want to take a guess what the name is? We have some options here. Linear, yeah. So linear function. Okay, now for the arrows, we're going to consider that when we give our answer for domain and range. Now for domain, we're talking about the independent values or the input, in this case the x values, right? So in this case, we're going to consider all real numbers. And instead of writing the whole thing, all real numbers, we're going to use the interval notation, and that will be from negative infinity to positive infinity. All right, so let's do that. Negative infinity to positive infinity. For the range, that will be the output or your y values. In this case, we can see the graph keeps going and going and going and going, right? So there's no like smallest specific number, and we also don't have like a largest specific number. So it is all real numbers. So once again, we will use the interval from negative infinity to positive infinity. Okay, the next function, that one is also part of the Algebra 1 class. So anyone would like to take a guess what the name will be? Jen, I know you know. Quadratic, very good. So quadratic. And you might be thinking, wasn't it called parabola? Parabola is the shape of the graph, but the name of the function is quadratic. Now, again, I want you to include some arrows here. Remember, these are screenshots from a graphing calculator. Okay, so the arrows are important because when we talk about the x values, this parabola is going to keep getting, as we go, it's going to keep getting wider and wider, and so if we look at the equation, you don't need to draw that. Let me erase it. If we look at the equation, think about something. Could you square any number? How about 100? Could you square 100? Yes. How about 9,000? Yes. So the domain becomes pretty large, right? And it could also be pretty small. So again, we're going to use all real numbers. And we will use the integral notation that we have here, so from negative infinity to positive infinity. Okay, now for the range, remember we're talking about our y values, or the output. So think about something. Justin, if I square negative 2, well, what will my answer be? Negative 2 times negative 2? Positive 4, and I like that you added that positive in front of it. So, Luis, if I square a positive number, 3 times 3, what do you get?
3. You square it?
Well, 3 squared.
Okay.
Or 3 times. 9. So positive again, right? So it doesn't matter what your number is, what your input is in terms of negative or positive, the answer will always be positive. So what will be the smallest y value here that you guys could see? 0. Now, I want you to make a little note. Just find some room on your paper. So we will say we're going to use parentheses if the number is not included. And we're going to use bracket, a square bracket, if the number is included. Now the question here is, should we include 0? Stand up if you think yes. Okay, yes, we should include 0 because 0 squared is the same as 0 times 0. And what is 0 times 0? 0. So if our input was 0, our output will be 0. So yes, we include 0. So because of that, we will use brackets. So from 0 to, and then the arrows denote that the y values will get larger and larger, and we will use infinity. Now, have you guys noticed that I don't use the bracket with infinity or negative infinity? Okay, so the reason for that is that infinity or negative infinity, they're just a concept. They're not a set numerical value, okay? So because of that, we don't say including infinity, all right? There are actually books written on that, on what infinity is. All right, so the next one. Again, I want you to draw some arrows. And also, I want you to do something here. And this is one of the biggest mistakes with the graphing calculators. You guys see on the picture that it kind of looks like it's ending there? Like right here? It actually does not stop there. It keeps going and going. And also, it's not really going to touch the x-axis. So I'll talk about that in a minute. Okay. And then for the next one, same thing. I want you to include an arrow. Extend your line without touching the x-axis, and then we'll have another arrow there. Now, you guys notice that the x is located in a very specific place, right? Okay, so Marco, what do you think the name of the function will that be?
Exponential.
Very nice guess. Yes. How do you know that?
Is exponential. There's two options.
Oh.
And there's also.
Okay, that's a very way to get the answer. Oh. Now, if you had to pick one for growth and one for decay, Leisha, what would you say is growth?
Well, both of them are going up. But
Well, remember, we will read them from left to right. So follow the marker.
over 4, no, 3 would be growth.
Very good. So that will be growth. And the other one will be decay. Okay. Now, another way to, I was kind of expecting for you, Marco, to tell me this, because the x is the exponent. But actually, what you did was very good, very smart, process of elimination. All right. So for both of them, exponential growth or decay, they're the same function. I just refer to them as exponential functions. We're going to spend a lot of time with those next semester, in the spring semester. And I love teaching those because there are a lot of like real world problems that are very applicable to these functions. Okay? Do you guys like zombies, for example? Yes? Zombies reproduce at a exponential rate. Okay. Also, for example, you start with one solving, it makes 2, and then from those 2 you go to 4, and then those 4, each one makes 2, so that will be 8, and then it keeps going like that. So that's like exponential rate. Also population, they increase or they may decrease at an exponential rate as well. Okay. So we're going to do a lot of those problems that are very related to chemistry, to biology, and even human geography. Okay, so domain for those, do you guys see how I have my arrows, right? That means, could we have exponents that are positive or negative? Yes. Could we have exponent that equals 0? Yes, yes we can. In fact, anything to raise to the 0 power, except for 0, let's say 4 to the 0 power is equal to 1. 3 to the 0 power is also equal to 1. But we will review these rules later on, okay? I don't want you to stress about it for now. So the domain, we're going to say it is, moreover, exponents could be fractions, they could be rational numbers, irrational. They could be whatever you want. If you don't understand one of the words, we're going to define more terms later on, okay? So in this case, from negative infinity to positive infinity for both exponential growth and decay. Okay. Now for the range. What would you guys say is the smallest y value here? You can't really tell, right? But if you had to pick one, what would you pick? 0. Yes, 0. However, I already told you that it's not going to touch the x-axis. In other words, it will never be 0. So what I'm trying to get here is we exclude 0. So we're going to use parentheses. And what that means is that the graph will get closer and closer to 0, but it will never be 0. And we're going to do some problems after this that will maybe make this a little better for you. Okay, and then the arrow, it keeps going up, so this one is going to increase, of course. So the largest y value will use the concept of infinity. Okay, now for exponential decay, I'm not going to say from infinity to 0 because I always want to give my answer from smallest to largest, okay? So we will use the same as the one here. The range will be, the smallest y value could be 0 without including 0. That's why I use parentheses. And it goes to infinity. Now, in terms of increasing and decreasing, Jasmine, what would you say 3 is doing? Is it increasing or decreasing? Increasing. And then, Javier, what would you say about number 4? Is it increasing or decreasing? Say that again?
Decreasing.
Decreasing. Very good. And I know that someone told me earlier, well, both are going up. But remember, we have to read our graphs from left to right. Okay? So very good. Very good answer. All right, next one. We have, we talked about that one last week, right? What's the name for it? Alexis. Yes.
Absolute value.
Very nice. So absolute value. And it kind of looks like a parabola, except that it has that sharp corner there. It's not curvy. So for the domain also, before we write out the domain, please throw some arrows there. And so the domain will be from negative infinity to positive infinity. Remember, we can take the absolute value of any number. However, for the range, Victoria, what would you say the smallest y value will be? 0. Very good. Now, Matthew, should we include 0? What do you think? Yes or no? So we use brackets. So from 0 to infinity. I want to remind you, this is only a preview. Do not stress about not understanding all the functions. We're going to spend a lot of time on each function. Okay? All right, number 6. That one is called rational. It has other names, for instance, reciprocal for the parent function. But I don't want to overwhelm you with that. So rational function. Now, I want you to do the following here. Again, technology, little error. It's not going to touch the x-axis or the y-axis. So go ahead and extend it, but without touching the x or y-axis. Also, I would like for you to do the following. I want you to, if you have a different color highlighter, pen, whatever you want to use, to draw a dotted or dashed line along the y-axis. And do the same for the x-axis. Okay, so let's talk about those, and I'm going to try to not to spend so much time on that. So we have something called a vertical asymptote. And then we have something called the horizontal asymptote. Okay. Now the vertical asymptote for that particular function is going to be the y-axis. But the equation for it, and please don't stress about this, we're going to cover it. It is x is equal to 0. Or you may remember from Algebra 1. Okay, now for the horizontal asymptote, we're using the x-axis. But for horizontal lines, we use the variable y, and that equals to a constant. In this case, that number is 0. So the vertical asymptote will be this line, and the horizontal asymptote will be that one. Okay, so why do we care about those? Because that is going to help you determine the domain and the range. Okay? Now, I don't want to get into what is the asymptote and all of that until we get to those functions, but I'll give you a brief explanation. It will be think of it as a line that the graph will get closer and closer to, but it will never touch it. Okay? So for the x values, and think about a point here at the origin. Would you say that the graph includes that point at the origin? Before I drew all this stuff. No, right? It doesn't really go across the origin. So somehow that graph is telling me like the point 0, 0 is not part of the graph. Okay, now let's look at the equation, and you have 1 over x. So think about the following. Could we divide by any number? Could the x be any number? There's one number that we are not allowed to divide by. In this case, what will that number be? 0. 0. Because if we try to find f of 0, it will be 1 over 0, and that is undefined. Okay? So because of that, we need to exclude 0 from the domain. So we're going to do that with the following way. We're going to say all real numbers except 0, and this is how we do it. We start from negative infinity, we stop at 0, and then we use parentheses to exclude it, and then we set our second interval from 0 to positive infinity. And we're going to connect them with, it looks like an uppercase U, and that is a union symbol. So because we have that vertical asymptote at x equals 0, it also means that for the domain, exclude 0. All right. Now let's look at the horizontal asymptote. So because we have the horizontal asymptote as y equals 0, that means that we will exclude for the range, or to state your range, we're going to exclude y equals 0. Okay? So same thing here, from negative infinity to 0, union 0 to infinity. Okay? I don't want you to feel overwhelmed if you don't understand this. I promise you that we will spend a few weeks talking about those graphs and functions. Okay, we have 2 left. Number 7, it is the logarithmic function. And something interesting about that is that, about those functions, is that they are inverses of exponentials. Okay? If you don't understand what an inverse is, don't worry, we are going to cover it. But in short terms, I could tell you that one will undo the other. Okay? All right. So logarithmic, I want you to do the following here. Again, we need arrows. And also, this really bothers me about graphing calculators. It also keeps going without touching the y-axis. Okay, now the domain, this one also has a vertical asymptote. So for the domain, do you guys think we should include x equals 0 or not? If I'm telling you there's an asymptote, that means it's going to get closer and closer, but it will never be 0. Okay? So then we use parentheses. And what would be the largest x value? Infinity, so we use the symbol for infinity. Okay, thank you. And then now, what about range? What do you guys think? Lauren, what do you think? What will be the smallest? Follow my hand. Huh? But with the negative sign. So negative infinity. And then what will be the largest, Isaac?
Positive infinity.
Positive infinity. So we go from negative infinity to positive infinity. That was really ugly. Okay. So arrows, remember, it means it extends indefinitely, right? Okay. And then we have one left. I think you all can tell me the name. Square root. Very good. We also call these functions radical functions, but we're not going to get into that yet. And then I want you to do the following with the graph, with the picture of the graph. This will be a point, and then here we have an arrow. So that's the starting point at the origin, and then the arrow going to positive infinity. Okay, so for domain, Catherine, what do you think will be the smallest x value? 0. Should we include 0? Yes, very good. And think about this. Could you take the square root of 0? Yes, it's 0. So from 0 to what? Infinity. Very good. Now, what about the range? 0 to infinity. Should we include 0? Yes. Okay, so this will be the end of the video.